Alright, so chapter 8 is on using something called rational expressions, and rational expression is just a fancy word for a fraction or a ratio. Okay, that's what a ratio is. A ratio is just a fraction like 2 over 3 or something similar. So the first two sections are on learning how to simplify these, and usually multiplying and dividing are harder than adding and subtracting, but with rational expressions they're easier. So that's the two goals for this, is we want to learn how to multiply them and how to divide them. Okay. And actually, even before that, I should say we want to learn how to simplify them. So here's how you simplify them. In general, when they tell you to simplify, that just means factor anything that you can factor. So I cannot factor that 5x, so I'm going to leave that alone. I can factor this, though. We're looking for numbers that multiply to 3 and add to 4. And the numbers that do that are 3 times 1 and 3 plus 1. So x plus 3, x plus 1. And if we do this correctly, normally what will happen is when we factor the bottom, something will be able to cancel out. So if you look at, let me change the color here, if you look at this one, that's a difference of squares. That factors to x plus 3 times x minus 3, and the reason we did that is because now we can cancel these out. And so the simplified version is 5x times x plus 1, that takes care of these two, over x minus 6 times x minus 3. And you don't have to multiply that, you can just leave it exactly as it is. So there's the simplified version. So at least a little bit simpler than what we started with. Second question here, under what conditions, I should say, is this expression undefined? And the answer is it's undefined whenever the bottom of this fraction is equal to 0. It doesn't matter if the top is 0, but we're not allowed to divide by 0. So what would make this undefined if x were equal to 6? That would mean this whole parentheses was 0, and we can't divide by 0. Right here, it would be undefined when x equals negative 3. That would make this 0. And you still include that even though we canceled it out, by the way. Even though we canceled out this x plus 3, that's still part of what would make it undefined. And then right here, what would make that 0? X equals 3. So you set all of the parentheses in the bottom equal to 0. And those three green ones that I circled, that's the answer to the second question. It's undefined when x equals 6, when it equals 3, and when it equals negative 3. Alright, let's do one more of these. We'll do, we'll do the one on the, trying to see which one better. The one on the right, or the left, I should say, is a little bit better. So the top has already been factored for us, so we don't have to do anything with that. Okay, the bottom, though, can factor. What numbers multiply to negative 6, add to negative 1? And the answers would be negative 3 times positive 2. Negative 3 times positive 2 is negative 6, negative 3. Plus 2 is negative 1. Okay, so this is simplified. We can cancel these. So the final version would be 4y times y plus 4 over y times y plus 2. Okay, the question is, what would make the bottom equal to 0? Because that's when this would be undefined. They're asking us that right here. So the bottom would equal 0 if y equals 3. That would cause this thing to be 0. If y equals negative 2, that would make this 0. Or if y equals 0. If you plug in 0 for y right there, that makes the whole thing equal 0. So that's how we would answer. Alright, this one is not even asking us to simplify, it's just asking us what values would make it undefined. So we don't even really need to factor the top. The bottom one factors to numbers that multiply to 8 and add to 6 would be plus 4 and plus 2. And so what would make this undefined? Negative 2 would cause that one to be 0. Negative 4 would cause that one to be 0. And 0 would cause that one to be 0. So 0, negative 4, and negative 2. It looks like the only one that has that is option C right there. Okay. And actually, let me just double check there. Is that going to cause a problem? It might not, though, because we can cancel out this x and that x right there. And so that means that the x is actually not, technically it's not even there. So I don't think they're going to, no, it still matters. We still need to include the 0, even though that could simplify. Alright, let's continue on. So this one, simplify this one. Now here's the thing, we'll start by simplifying the top. This one right here, this has a common factor of w, so we'll pull out a w. And what's left behind would be 4w minus 3y. I got that by dividing this and this each by w. And then we have that other parentheses right here. The bottom is 3y minus 4w and 5w plus y, I should say. So here's the problem. If you look at it, we can almost simplify it. This one right here almost looks like this one right here. It's just this one is 4w, that's negative 4w. So what you can do in this case is you could factor out a negative right here. If you pull out a negative from here, you'll get negative 3y. If you pull out a negative from here, you'll get 4w. So now we are able to cancel these. Okay, that's a technique that you might sometimes have to use, which is if they look almost the same, just with the signs reversed, you can pull out a negative 1. So now that simplifies down to this right here. This thing is covered right here. This thing is covered right here. The W is covered right here. And those, remember, canceled. And actually, I forgot one thing. We have a negative right there. So that negative still needs to be in front. Alright, let's do one more like that. Let's take a look at 3b right here. So 3b, if you look at the top right here, they both have an A and a B in common. So we'll pull out an AB. You pull out an AB from here, you're just left with B. And just to clarify where that comes from, the A's cancel, and that B cancels, and one of those cancels. That's why we're left with a B right here. And if you pull out an AB from minus 5AB, you just have minus 5. And the bottom becomes 5 plus B still. And then notice I have a B minus 5 here, I have a 5 minus B. So the way to fix that is to pull out a negative, which I'll put in front. If I pull out a negative from right here, the 5 becomes a negative 5. And the negative B becomes a positive B, and now we can do that technique we did before. So we're left with AB over negative 5 plus B, and that's exactly what they wrote. They just put the negative in front. Okay, how do you multiply and divide? These are simple expressions. We'll talk about the more complicated ones in a second. Just to remind you how to do this with numbers, I'll show you 2 easy ones, and if you can do these 2 easy ones, you can do any amount of hard ones. Okay, so let's say we had, let's do it with the numbers. We have 6 over 8 times, let's say, 12 over 4. So when you're multiplying numbers, the easiest thing to do is see if you can cancel things. I have a 4 on top, and I could cancel with anything on the bottom that 4 goes into. 4 goes into itself once. It goes into 8 twice. I could have also canceled it with the 12. It doesn't matter. 6 goes into itself once, and it goes into 12 twice. Okay, so now this is a lot simpler. 1 times 1 is 1, 2 times 2 is 2, and now that's simplified. Okay, that's the same idea we're going to use with these rational expressions right here. So let's start with the numbers, and we'll deal with the variables later. So 6 and 8. What goes into 6 and 8? 2 does. 2 goes into 6 3 times, and it goes into 8 4 times. Okay, then let's take a look at the 5 going into itself once, and it goes into 15 3 times. And then how about the variables? So let's simplify this. C times C would be C squared. 3 times 3 would be 9. Okay, D cancels with itself, and it cancels one of those 2 D's right there, because D squared divided by D is, you subtract those exponents, you just get D to the first. So our D to the first is right here. And then I still have an A on the bottom. So this is as simple as we can get it. There's nothing where we can cancel, there's no variables, and there's no numbers. Actually, one mistake here, I'm sorry, I didn't notice this. 1 times 4 should be 4. Okay, 9 over 4 does not simplify, so you would leave it like that. Okay, dividing by a fraction is the same as multiplying by the reciprocal, so that's what we're going to need to keep in mind for this one. So let me rewrite 18xy cubed over 7a squared b squared, and then dividing by this fraction here is like multiplying by its reciprocal, and the reciprocal just means you flip it over. So 35a squared b over 12x squared y. Okay, let's see now what we can cancel, if anything. I'm sure there's plenty. So 7 goes into itself once, it goes into 35 5 times. 6 goes into 12 twice, and it goes into 18 3 times. The x's here will cancel. Y cancels here, and 1 out of these 3 y's cancels. That leaves us with 2 y's. A squared cancels, b cancels, and one of those 2 b's cancels. So as you saw in the last problem, you got to be careful when you're now multiplying this so you don't forget something. So 3 times y squared times 5. 3 times 5 is 15, so that's going to be 15y squared. And we covered everything there. This is 1, that's gone. That's a b, that's a 2, and there's nothing else. So the bottom is just 2b. And that's as simple as we can make it. Alright, let's pick one more of these that looks kind of difficult. Let's try 4d. The division ones are always harder than the multiplying ones because you can, dividing is just one extra step. So we're doing 4d here. 12x to the 4th y squared over 40, a to the fourth, b to the fourth, and then dividing by this thing is like multiplying by its reciprocal, which means I'm going to flip 16a squared x to the top and 6x squared y to the fourth to the bottom, and let's see what we can cancel now. So we have 6 going into itself once, and it goes into 12 twice. 8 goes into 16 twice, and it goes into 45 times. And if you didn't know 8 went into it, you could simplify with 2, and then you have to do that a couple more times. Let's see what else we can cancel. So x to the x squared cancels, and 2 out of those 4 x's cancel, because I was canceling x to the 2 right there. 2 of those a's cancel, and 2 out of those 4 a's cancel. Let's see if there's anything else we can cancel here. So there's no b's to cancel. There is a y though. There's 2 y's cancel there, and 2 out of those 4 cancel. And now we have to be careful when we start multiplying this together. So let's start with the numbers first. 2 times 2 would be 4. Then we have an x squared, and we have an x. X squared times x is x to the third. Okay, and the bottom we have 5 times 1, that's just 5. We have b to the fourth times y squared, that's going to be b to the fourth y squared. And that's as simple as we can make it. So 4x cubed over 5, oh, we still forgot something, I forgot something. So you got to be careful when you write this, and I'm not being careful. There's a squared right there, so didn't notice that. Yeah, obviously I would suggest, and I'm not a good example of this apparently, but just be careful as you're going through. I would count each term as you go. So I didn't cancel this to make it look like the whole thing was canceled, but there's an a squared. Alright, okay, how do we multiply things? The easiest, so this would be a terrible mess if you tried to multiply it in its current form. The easiest way to do this is to factor everything that you can factor. And if we do it correctly, usually there's going to be things that cancel each other out. So let's factor the thing under x minus 8. What numbers multiply to 6 and add to 5? That would be x plus 3 times x plus 2. And if we do this correctly, probably one of these is going to show up right here. So what numbers multiply to negative 16 and add to negative 6? That's going to be negative 8 and positive 2. And notice these cancel each other out. That's what we wanted. And then finally down here, what multiplies to 64 and adds to negative 16? That's negative 8 and negative 8. So that cancels with this, and this cancels with this. So our final answer is just going to be the whole top part is 1, because everything canceled, and the bottom part is x plus 3. So you can see how much simpler this is versus this mess that we started with. Okay, division is the same thing. The only difference is we have to multiply by the reciprocal. So let's start by factoring this. The top is a difference of squares. That's x plus 4 times x minus 4 gives you x squared minus 16. The bottom has a common factor of 12, so I'm going to pull a 12 out from both of these, and we would be left with y plus 3. And then I'm going to multiply by the reciprocal of this. Okay, so this means this thing is going to go on top, y squared minus 3y minus 18, and this other one will go on the bottom. And then let's see if we can factor each of these. Let's start by factoring y squared minus 3y minus 18. What multiplies to negative 18 adds to negative 3? That would be minus 6 and plus 3. I'll just cross this out so we don't get it confused. And then the bottom, what multiplies to positive but adds to negative? There would have to be 2 negatives. And it's 8 times 4, which is 32, and 8 plus 4 is negative 12. Okay, so let's see what we can cancel now. This is usually the best part, is the canceling part, because you start to make this look a lot neater. So x minus 4 cancels, y plus 3 cancels, and I think that looks like it's everything. So we need an x plus 4 times a y minus 6 on the top, and trying to follow my own advice here, make sure we don't omit anything. And then we have a 12, and we have an x minus 8, and we don't have to multiply those out, we can just keep them as is. So we're done right there. One thing I want to point out that people make a mistake on, some people would say, can't you cancel this 4 and this 8? And you can't, and I'll show you why. That's not a 4 and an 8, that's an x plus 4 and x minus 8. So let's pick a number for x. Let's let x equal 1. So if x equals 1, we'd have 1 plus 4 over 1 minus 8. That's 5 over negative 7. Now let's try to cancel. So we'll make that 1, we'll make that 2. So that's going to be x plus 1 over x minus 2. We assume that x was 1, so let's plug it in. 1 plus 1 is 2. 1 minus 2, negative 1. This number does not equal that number. So that's just to show you it doesn't work. You can't cancel fractions unless they're just single numbers by themselves, not attached to the x. Alright, so the last couple things we want to do is show you how to simplify what's called a complex fraction. And complex doesn't mean complicated, it just means a combination of basically one fraction over another fraction. So these, I'll show you examples. There's a fraction over another fraction. And their advice is to first rewrite it as a division expression. So another way of saying this is a plus b over 4 divided by a squared plus b squared over 4. And remember, dividing by a fraction is like multiplying by the reciprocal. The reciprocal of this is 4 over a squared plus b squared. The 4's will cancel, and we'll be left with a plus b over a squared plus b squared. And we should not try to simplify that, because first of all, the bottom doesn't factor. If it was minus b squared, that would be a difference of squares. And then in that last page, I just showed you that you can't do this. You can't say, I'm going to cancel those. So similarly, we can't do that. If you don't believe that, you can plug in some numbers and test to see if it works, and it won't. Okay, this one right here is going to be this thing right here. And then we are dividing by a fraction that's like multiplying by the reciprocal of that, which is y minus x over 4x. So we can cancel this x, and we can cancel one of those. And then this thing right here is actually a difference of squares. This is x plus y times x minus y. This is almost the same thing as x minus y, it's just we need to pull out a negative, and now it's x minus y. So that will cancel, and that will cancel. And we have this negative times the x, so negative x, and we have the 4 times the x plus y, so 4 times x plus y. And that's as simple as it gets. Again, we cannot cancel those x's because that's the bottom is not really an x, it's an x plus 4, and we don't know, or sorry, an x plus y, and we don't know what y equals, so we're not allowed to cancel. Let's try one more of these. Let's do 6b. So we'll take this thing. The top is a difference of squares. That's x plus y times x minus y. And the bottom is also a difference of squares. That is y squared minus 49 is y plus 7 times y minus 7. And we're going to multiply by the reciprocal of that. The reciprocal of that is y plus 7 over y minus x. The y plus 7's will cancel. And this y minus x, I want it to look like this. It's very close to that. I can do that by factoring out a negative. So now that will cancel with that. And our final answer is going to be x plus y. That's what's left on the top. And the bottom has a y minus 7 and it has a negative. So we'll put a negative out front, and we'll put the y minus 7 there. And let's just verify. And they did that. The only difference is they basically took this negative right here and distributed to get this top part right here. Alright, and that is the end of 8.1. That's on multiplying and dividing rational expressions. So hopefully that makes a little bit of sense.